In this video, I'm going to go through the solutions to my 2025 Edexcel Paper 1 Higher practice paper. Before watching the video, I would highly recommend that you download a copy of the paper and try it yourself. You can get a free copy of it from my website, and there's also a link in this video's description. Just before I run through the answers, a brief disclaimer. This paper has been made using some of the most frequently occurring topics from past papers, but you still shouldn't consider it a predicted paper. Nobody can predict what topics are going to come up in your exams. If you see creators going on about how accurate their predictions were last year, this is simply to try and get you to pay for their paper. You should still make use of past papers and practice papers to support your revision, but if you truly want to succeed in maths, then you need to be prepared for all topics, and you don't need to spend a penny to do this either. There's plenty of free videos, papers, and booklets all over the internet that you can make use of. In this question, we need to write 7.2 times 10 to the power 5 as an ordinary number. 10 to the power 5 means 10 multiplied by itself a total of 5 times. So we can just take 7.2 and multiply it by 10 5 times. 7.2 multiplied by 10 once is 72. Multiply it by 10 a second time, that's 720. A third time would be 7,200. A fourth time, 72,000. And finally a fifth time, 720,000. So that's the answer as an ordinary number. In the next part of the question, we need to do the reverse process. We've now got an ordinary number, 0.0334, and we've been asked to write it in standard form. When we write a number in standard form, the first part needs to be between 1 and 10. If we look at the digits we have here, we can see 3, 3, 4, so the number we're going to need to use is 3.34, since that's between 1 and 10. Now we need to multiply this by a power of 10, and we need to work out what that power is. To do this, we're going to place a decimal point into the number as though it reads 3.34, so here. Then we need to work out if we need to multiply or divide this by 10 to get to 0.0334. Well, if we divide this number by 10 once, we'd end up with 0.334. And if we divide it by 10 a second time, we'd get 0.0334, the number we want. So we divided this number by 10 twice, which means we have the power -2. In this question, we need to show that 2 1/4 subtract 1 5/6 is the same as 5/12. We're going to start with 2 1/4, which is a mixed number, and convert it to an improper fraction. To do this, we multiply 2 and 4 together, which gives you 8, and then add 1, which gives you 9. So 2 1/4 is the same as 9 quarters. Then we'll do the same with 1 5/6. 1 times 6 is 6, and then add 5 is 11. So this is the same as 11 over 6. And then we're going to subtract these. At the moment, these two fractions have different denominators. When we subtract fractions, we need their denominators to be the same. So we think about 4 and 6 and think of a number that they both go into, a common multiple, and the lowest one that I can think of is 12. So we'll rewrite both of these as something over 12. So how would we convert 9 quarters into 12ths? Well, if we look at the 4 on the denominator, we must have multiplied that by 3 to get to 12. So we'll also multiply the 9 by 3, and 9 3s are 27. Then if we do the same idea with 11 over 6, what would we multiply 6 by to get to 12? That's multiplied by 2. So we'll also multiply the 11 by 2. 11 times 2 is 22. Now we have the same denominators, we can do the subtraction. 27 subtract 22 is 5. So we end up with 5 over 12, which is what we wanted to show in the question. In this question, Eden has been asked to express 330 as a product of prime factors. Her answer is 5 multiplied by 6 multiplied by 11, and we need to explain the mistake that Eden has made. Now, when you express a number as a product of prime factors, all of the numbers you use must be prime numbers. If we look at Eden's answer, 5 and 11 are prime numbers, but 6 is not. So when explaining the mistake here, we could say that the number 6 is not a prime number. In this question, we have a shop that sells a pair of shoes for £48 and a suit for £300. So a pair of shoes for 48 and a suit for 300. We're then told the price of the pair of shoes is increased by 25%. So let's find 25% of the price of the shoes. To find 25% of a number, you can divide it by 4. So 48 divided by 4 is 12. So 25% of 48 is £12. But the shoes are going to be increased by this price, so we need to add that on to the original price of 48. So 48 plus 12 is 60. So the shoes no longer cost £48, they now cost £60. We're then told about the suit. The price of the suit is decreased by X%, but since we don't know what X is, we can't use this right now. We're then told the price of the pair of shoes is now 1/3 of the price of the suit. So the new price of the shoes, which is 60, is 1/3 of the new price of the suit, which we don't know. But if it's 1/3 of the price, if we multiply it by 3, we'll find the price of the suit. So £60 multiplied by 3 is £180. So the new price of the suit must have been £180. Now we're asked to work out the value of X in this question. So we can return to the part where it said the suit is decreased by X%. So we just need to work out what percentage we would decrease 300 by to get to 180. To do this, we first of all work out the difference between the two prices. So 300 subtract 180, which is 120. So we know the suit has decreased by £120, but we need to work out what percentage this represents. To do this, we take the £120 and express it as a fraction over the original price, which was 300. So 120 over 300. And then we just need to work out what percentage this represents. You can actually divide both of these by 3. 300 divided by 3 is 100, and 120 divided by 3 is 40. This is especially helpful because now we can see clearly that this is 40%, since 40 over 100 is the same as 40%. So the suit must have decreased by 40%, so X must be 40. In this question, we have a probability tree diagram that's been drawn for us, and we need to work out the probability that Reese passes exactly one of his tests. So for Reese to pass exactly one of these tests, he could pass the Spanish test, which is great news, but then he could fail the French test. So this is passing one of the tests, just Spanish. Or alternatively, he could fail the Spanish test, but then pass the French test. This is still passing exactly one of the tests. Now all we need to do is work out the probabilities of these outcomes. Let's start with passing Spanish and failing French. To work out the probability of this happening, we multiply the probabilities along the tree diagram. So 0.3 and 0.6. If you multiply 0.3 and 0.6 together, you get 0.18. Then we'll do the same thing for failing Spanish but passing French. So 0.7 and 0.4, and if we multiply those together, we get 0.28. Now, since these are both acceptable ways of passing exactly one test, we need to add both of these probabilities together. 0.18 plus 0.28 is 0.46, and that's the answer to the question. In this question, we need to work out 2 to the power 5 multiplied by 3 to the power negative 2. Let's start with 2 to the power 5, which means 2 multiplied by itself a total of 5 times. 2 times 2 is 4, times 2 again is 8, and times 2 once more is 32. For 3 to the power negative 2, we're going to consider 3 to the power positive 2 first, or 3 squared, which means 3 times 3. And 3 times 3 is equal to 9. When we consider 3 to the power negative 2, we just do the reciprocal of 3 to the power positive 2. So the reciprocal of 9, which is 1 over 9. So we take 32 and 1 over 9 and multiply them together. To do this, we could rewrite 32 as 32 over 1. Now if we multiply the numerators, 32 times 1 gives you 32, and on the denominators 1 times 9 is 9. So we're almost finished, but the question says give your answer as a mixed number. So we need to convert this improper fraction back to a mixed number. To do this, we think about how many 9s go into 32, which is 3, since 3 9s are 27. Then we need to think about how many are left over. To get from 27 to 32, you need 5 more, so the remainder is 5. And the denominator stays the same at 9. This is now a mixed number, so we have finished the question. For the first part of this question, we need to show the volume of the prism is less than 27 centimeters cubed. To work out the volume of a prism, we do its area of its cross-section, so the area of this triangle, which would be 1/2, multiplied by the base, which is 2.8, multiplied by its perpendicular height, which is 4.8. Once we found the area of the cross-section, to find the volume, we multiply it by the length of the prism. And the length of this prism is 4, so multiplied by 4. So this calculation here will work out the volume of the prism. Now, since we're just multiplying numbers together here, we can change the order of this into any order we like. And I'm going to do 1/2 times 4 first. 1 half multiplied by 4 gives you 2, since half of 4 is 2. Then I can do 2 multiplied by 2.8, which is 5.6. So I just need to multiply 5.6 and 4.8. To multiply these together, I'm temporarily going to imagine the decimal points aren't there, so that it reads 56 multiplied by 48. And I'll do this instead. So 56 multiplied by 48. To do this, I will do 8 times 6 first, which is 48. And then 8 times 5, which is 40, but add that 4 that I carried, so 44. Then we move on to the 4, but this 4 represents 40, so I need to put a 0 placeholder down. Then I do 4 times 6, which is 24. And then 4 times 5, which is 20, but add that 2, so 22. Now I can just add these two numbers together. 8 add 0 is 8. 4 add 4 is also 8. 4 add 2 is 6, and then just 2. So this gives us 2,688. But that wasn't the question we needed to do. That was 5.6 multiplied by 4.8. But this calculation will still have the same digits, so 2688. We just need to work out where the decimal point goes. To do this, we think about how we can get from 5.6 to 56. Well, that's just multiplied by 10. And 4.8 to 48, that's also multiplied by 10. So altogether, we've multiplied by 10 and 10, which is 100. So our answer must be 100 times too big at the moment. So we just need to divide it by 100, and we'll get the true answer, which is 26.88. And you can see that's very close to, but slightly less than 27, as the question wanted us to show. In part B of this question, we need to work out the total length of all of the edges of the triangular prism. Now, some of these edges we have the lengths for. We can see this one here is 2.8. But because the shape is a prism, the cross-section must be constant, so this length here is also 2.8. Then we have the length of the prism, which is 4, and that means this must also be 4, and this must also be 4. Then we have this diagonal height here at 5. That must be the same on the front triangle too. And because in the question it tells us the triangle's isosceles, this will be 5, and this will be 5. So to work out the total length of all of the edges, we just need to add all of these numbers together. So we've got the two 2.8s, the 3 4s, and the 4 5s. 2.8 add 2.8 is 5.6. 4 add 4 add 4 is 12. And 5 add 5 add 5 add 5 is 20. And if you add all of these together, you get 37.6, which is the answer to this question. In this question, we're told a bag contains 100 counters that are either red, green, or blue. We're told the ratio of the red counters to green counters is 4 to 1. This isn't useful at the moment because we don't know how many blue counters there are. However, in the next sentence, we're told that 1/4 of the counters are blue. So if we find 1/4 of 100, which is 100 divided by 4, you'll find that there are 25 blue counters. Now if there are 25 blue counters, we can subtract this from the total number of counters, so 100 subtract 25, to get 75. This means there must be 75 counters that are either red or green. Now we can return to that ratio from before. If we create a ratio table of red to green, and then do a total column, the ratio of red to green was 4 to 1, this gives a total of 5 parts in the ratio. Now we know that the total number of red and green counters is 75, so we can write this 75 in the total column underneath 5. Now what do we multiply 5 by to get to 75? Well, that's 15. So we can multiply the 4 and the 1 by 15 as well. 4 15s are 60, and 1 15 is 15. This tells you that of those 75 counters, 60 must be red and 15 must be green. So we now know how many of each colour there are. There are 60 reds, 15 green, and 25 blue. Next we're told the mean mass of each of the counters by their colour, and we're asked to show the mean mass of all of the counters is less than 5 grams. Let's just focus on the red counters. The mean mass of the red counters is 6 grams, and we know there are 60 of them. So to work out the total mass of all 60 of these red counters, we can multiply 60 by 6. This will give you 360 grams. So the total mass of all of those red counters is 360 grams. If we do the same for the green counters, we need to multiply the 15 green counters by their mean mass, which is 2, to get a total mass of 30. And if we do the same for blue, 25 times 4 is 100. So we now know the total mass of each of the counters by colour. if we add together all of these masses, we'll get the total mass of all of the counters. If you add these together, you get 490. Then to find the mean mass, we divide the total mass, which is 490, by how many counters there are. So 490 divided by 100, which is 4.9. And for this question, we had to show the mean mass was less than 5, so we'll state that 4.9 is indeed less than 5. In this question, we're told that ABCD is a kite. This means that the length here, AD, must be the same as the length AB. So this is also 2x plus 1. And also the length BC here must be the same as the length DC, so this one's also 4x plus 12. We're told that BC is equal to 3 multiplied by AD. So if we take BC, which is 4x plus 12, this must be equal to 3 lots of AD, which is 2x plus 1. So we can form this equation here. To solve this equation, I'll expand the bracket on the right-hand side. So the left-hand side can stay the same, and on the right-hand side I do 3 times 2x, which is 6x, and 3 times 1, which is 3. Now I can subtract 4x from both sides. On the left-hand side, this will cancel the 4x, so I've just got 12. And on the right-hand side, 6x take 4x is 2x, so I have 2x plus 3. Next we would subtract 3 from both sides. 12 take 3 is 9. And on the right-hand side, the 3's will cancel, so we just have 2x. Finally, divide both sides by 2. 9 divided by 2 is 4.5. And 2x divided by 2 is just 1x. So we found that x is equal to 4.5. In this question, we've been asked to work out the perimeter of the kite. This means we need to know the lengths of all of the sides. At the moment, the sides are given in terms of algebra, but we now know that x is 4.5. So to find the lengths of the sides, we can just substitute in 4.5 for x. Let's do this with 2x plus 1 first. So instead of 2x plus 1, we have 2 lots of 4.5 plus 1. 2 4.5s are 9, and if you add 1, you get 10. This means that both of the sides with a length of 2x plus 1 are actually 10. If we do the same idea for 4x plus 12, we need to do 4 lots of 4.5 plus 12. 4 lots of 4.5 is 18, and if you add 12 to that, you get 30. So both of the sides with length 4x plus 12 are actually 30. So we have 10, 10, 30, and 30. And to get the perimeter, we just add these together. So 10 add 10 add 30 add 30, which gives you a total of 80. So the answer to this question is 80 centimeters. In the first part of this question, we need to draw a box plot. We can see the lower score is 22, so we can draw a vertical line at 22. We're then told the range is 60, and the range is the difference between the lowest score and the greatest score. So if we add 60 to the lower score, we'll find what the greatest score was. So 22 plus 60 gives you 82. So the greatest score must have been 82, because 82 take 22 would give you 60. So we can draw a vertical line at 82 for the greatest score. Then we have the median at 38, we can put that straight onto the diagram at 38. And the lower quartile at 30, that can also go straight onto the diagram. And finally we need the upper quartile, but we haven't been given that, we've been given the interquartile range at 40. But the interquartile range is the difference between the lower and upper quartiles. So if we add the interquartile range to the lower quartile, 30 plus 40 gives you 70. This means the upper quartile must have been 70. Since then, 70 take away 30 gives you 40. So we need to draw a vertical line at 70 for the upper quartile. To complete the box plot, we draw horizontal lines connecting the lower quartile through the median to the upper quartile, and then also 2 more lines like this connecting the lowest value to the lower quartile and the greatest value to the upper quartile. And that's the completed box plot. For the second part of the question, we need to estimate the number of Year 7 students who scored less than 30% on the test. Well, we should notice that 30% was actually the value of the lower quartile. There are 25% or 1/4 of the data values below the lower quartile. So we can deduce that 25% of these students must be below 30%. In total, there were 200 students mentioned in the question, so we just need to find 1/4 or 25% of 200. We can do 25% of 200 by dividing 200 by 4, which will give you 50. So the answer to this question would be 50. In this question, we need to expand x plus 2 all cubed. When you cube a number, you multiply it by itself a total of 3 times. So we need to do x plus 2, multiply by itself, and multiply by itself again. To approach this, we're going to expand these first two brackets and write the answer inside this big bracket here. And then we'll multiply whatever we get from that by the final x plus 2. So let's expand these two brackets. X multiplied by x is x squared. X multiplied by plus 2 is plus 2x. 2 times x is also plus 2x, and then 2 times 2 is plus 4. This will actually simplify because we have 2x out of 2x, which is 4x. So we end up with x squared plus 4x plus 4. Now we need to multiply this by x plus 2. We'll start by multiplying x squared by x, which is x cubed, then x squared by 2, which is plus 2x squared. Now we move along to the 4x, so 4x times x, which is 4x squared, then 4x times 2, which is 8x, and then we move along to the 4, so 4 times x, which is 4x, and then 4 times 2, which is 8. Now we're almost finished, we just have to do some simplifying. We have x cubed, which is just x cubed, but then we have 2x squared add 4x squared, which is 6x squared, and then 8x plus 4x, which is 12x, and then we have just this plus 8 at the end, so plus 8. And this is your answer to the question. In the second part of this question, we need to make x the subject of this formula. At the moment, we can see that k is the subject because it's the letter that's on its own. So we need to rearrange this so that x is on its own. We'll start off by multiplying both sides by 7 minus x. On the left-hand side, this will cancel the 7 minus x and just leave us with pi. On the right-hand side, though, we need to multiply k by 7 minus x. So we get k lots of 7 minus x. On the right-hand side, we can expand this bracket. So we've got pi on the left, and then k times 7, which is 7k, and then k times negative x, which is negative kx. Now, we want to make x the subject, and at the moment the term including x is negative, so what I like to do at this point is add that term to both sides. So I'm going to add kx to the left side, which would just be pi plus kx, and on the right hand side if I add kx, that will cancel the subtract kx, so I just end up with 7k. Now I can subtract pi from both sides. On the left this will cancel the pi, so I just have kx, and on the right if I subtract pi, I have 7k subtract pi. Now the final step is to divide both sides by k. On the left hand side this will cancel the k, so I'm just left with my subject x. And on the right hand side, if we divide by k, we have 7k minus pi, divide by k. We can now see that x is the subject because x is on its own, so we have x equals 7k minus pi over k. You may have also written this as 7 subtract pi over k, where just the pi is divided by the k and not the 7. In this question, we need to do an enlargement. The first thing we're going to do is mark on the centre at 0, 2. So let's mark across at 0, 2. Then we're going to look at the scale factor, which is negative 3 over 2. 3 over 2 is 1.5, so this is negative 1.5, or negative 1.5. Now what we want to do is pick a point on this shape A. I'm going to start with this one here. Since we're doing a negative enlargement, we're going to go back past the centre of enlargement. So what I'm going to do is count how many squares it is from my point to the centre of enlargement, which is 1, 2 squares, and then I'm going to do this journey again, and then half again, because it's negative 1.5. So if I do the journey once more, I need to do another 2 squares, and then if I do half of the journey, I just need to do 1 square. So this first point would map to here. Now let's pick a second point, and repeat the same process. So how do we get from this point to the centre of enlargement? It's 2 right, and 2 up. So we'll do that journey 1.5 more times past the centre of enlargement. So if we do it once more, we need to repeat 2 right and 2 up, and then half of that journey would just be 1 right and 1 up. So we'll go 1 right and 1 up. So this point would map to here. Let's try another one. So we'll go for this one down here. To get from this point to the centre of enlargement, I go 1, 2, 3, 4, and then 2 up. So 4 right, 2 up. So let's repeat that journey once more. So 1, 2, 3, 4, 1, 2, and then half of that journey again. So half of it would be 2 right and 1 up. So 1, 2 right, and 1 up. So it'll go here. And now we've just got one more point to do, which is this one. So to get from this point to the centre of enlargement, we go 1, 2, 3, 4 right, and then 1, 2 down. So we'll do that once more. 1, 2, 3, 4 right, 1, 2 down, and then half of that journey again. So instead of 4 right, 2 right, and instead of 2 down, 1 down. So 2 right, 1 down. And that point maps to here. If we now join up all 4 of these points, you can see the enlarged shape. In this question, we need to work out the total surface area of this shape. This means we need to work out the area of all of its faces. Let's start with this rectangular face here. To find the area of a rectangle, we just multiply the base and the height. So this one would be 8 multiplied by 10, which is 80. Then we'll move on to this semicircle face here and this semicircle face here. If we take both of these semicircles and join them together, they make a full circle. So we just need to find the area of this circle. We can see from the diagram the diameter of this circle must be 8. This means the radius is half of this, which is 4. So we just need to use the formula for the area of a circle, which is pi times the radius squared, so pi times 4 squared. 4 squared is 4 times 4, which is 16, so we have pi times 16, which is 16 pi. So we've now found the area of 3 of the surfaces. We just need to do this curved surface here. To find the area of the curved surface area of a cylinder, we do pi times diameter times height. So if this were a full cylinder, we would do pi times the diameter, which is 8, times the height of the cylinder, which is 10. 8 times 10 is 80, so it would be 80 pi. But this is not a full cylinder, this is half of a cylinder, so we need to divide this by 2. 80 pi divided by 2 is 40 pi. So we now know the curved surface must be 40 pi. To work out the total surface area, we just add these together. We can simplify the 16 pi and 40 pi, so we have 80, and then if we add 16 and 40, we get 56, so it's 56 pi. And that's the answer, 80 plus 56 pi. For this question, we need to express 0.23 recurring as a fraction. To do this, we start by saying that x is equal to 0.23 recurring. We then multiply this by 10 to get 10x, and to do this, you can imagine all of the digits are moving one place to the left. What we then look for is that all of the digits after this decimal point line up with the same number. Unfortunately, at the moment they don't because we have 3 here and 2 here. So we multiply by 10 once more, which would give you 100x. And all of the digits move one to the left again, so it's 23.3 recurring now. We can now see that for the 100x and the 10x, all of these digits line up, so we can subtract these two to work out the answer to the question. So if we ignore the 1x and do 100x subtract 10x, 100x subtract 10x is 90x, and this is going to be equal to 23 subtract 2, which is 21, and all of these 0.3s here will cancel to give 0.00000, which of course is just 21. So we find that 90 lots of x must be 21. We can now divide both sides of this equation by 90. 90x divided by 90 is just 1x, and 21 divided by 90 is 21 over 90. So we find that x is equal to 21 over 90. But x was also 0.23 recurring, so this fraction must be the same as 0.23 recurring. The only thing we need to do is simplify this because it does ask us to give it in simplest form. 21 and 90 both have a factor of 3, so we can divide them both by 3. 21 divided by 3 is 7, and 90 divided by 3 is 30. So the answer fully simplified is 7 over 30. For this question, we're told that y is inversely proportional to x, which we can write down as y is proportional to 1 over x. We can replace this proportional sign with equals k, so we write y equals k over x. Then we're told that y is 0.4 when x is 50, so we can just substitute those values into this formula. Let's replace y with 0.4, and this equals k over x, which is 50. We can now find the value of k by multiplying both sides by 50, so 0.4 times 50 will equal k. And if you do multiply 0.4 and 50 together, you'll get 20. So k must have been 20. If we now rewrite the formula y equals k over x, but replace that k with 20, we have y equals 20 over x. The question asks us to work out the value of y when x is 20, so all we need to do is substitute x for 20. So y will equal 20 over x, but x is 20, so 20 over 20, and 20 divided by 20 is 1. So we found that y would have been equal to 1, and that's the answer to the question. For the first part of this question, we need to find the inverse function for f. So we write out the function f of x is 2x plus 1, and we're going to change the f of x for a y. We then switch all of the y's to x's and all of the x's to y's. So let's turn this y into an x, and then when we have 2x, we're going to turn the x into a y, so that's 2y, and then plus 1. Next, we need to rearrange this to make y the subject. We can start this by subtracting 1 from both sides. On the right hand side, if we subtract 1, we get 2y because the 1's cancel, and on the left hand side we have x, and then we subtract 1, so just x subtract 1. Then we can divide both sides by 2. On the right hand side, if we do 2y divided by 2, we get 1y, and on the left hand side if we divide by 2, well, we have x minus 1, and then we divide it by 2. Now that we've got y as the subject, we can replace it with inverse f of x, and now we have the answer to the question. The inverse function is x minus 1 over 2. For the second part of the question, we need to work out fg of square root 3. We can find this by doing g of square root 3 first, and then whatever we get from that we put into the f function. So let's do g of square root 3, which means we substitute square root 3 into the g function. So the g function is 5 minus x to the power 4, so it's 5 minus square root 3 to the power 4. Now let's think about square root 3 to the power 4. This means square root 3 times by itself a total of 4 times, so square root 3 times square root 3 times square root 3 times square root 3. Now if we multiply the first two of these square root 3's together, we get square root 9, which is just 3. And if we do the same with the other two, that's also 3. So we actually have 3 times 3, which is 9. So square root 3 to the power 4 is just 9. So this is actually just 5 minus 9. If you do that, you end up with negative 4. So we found that g of square root 3 is negative 4, and we now need to put that inside the f function. So we're going to do f of negative 4. F of x is 2x plus 1, so let's replace the x with negative 4, it will be 2 lots of negative 4 plus 1. 2 lots of negative 4 is negative 8, so negative 8 plus 1, which is negative 7. And that is the answer to the question. In this question we have a quadratic inequality to solve. The first thing we're going to do is factorize this quadratic. We're looking for two numbers that multiply to make positive 18, but add to make negative 9. This will be negative 3 and negative 6. So when we factorize this, we end up with x subtract 3, x subtract 6 is less than 0. What we now do is imagine we solve this as though it was actually equals rather than less than. So if this were a quadratic equation, we'd have x minus 3 equals 0, and x minus 6 equals 0. On the left one, if we add 3 to both sides, we get x equals 3, and on the right one, if we add 6 to both sides, we get x equals 6. So if this were a quadratic equation rather than a quadratic inequality, these would be our solutions. These become our critical values when solving the quadratic inequality. The easiest way to do this is draw a sketch of the graph of this equation. So if we drew the graph of y equals x squared minus 9x plus 18, we know it would cross at these two critical values of 3 and 6. We know it will be a U-shaped quadratic, so it will look something like this, crossing at 3 and 6. Now since we want x squared minus 9x plus 18 to be less than 0, we're interested in the part of this graph that's below the x-axis. That's this one here. Had it been greater than 0, we would have been looking at the part of the graph that's above the x-axis. We now need to consider which x values would give us this section of the graph. Well, that's the x values that are greater than 3 and less than 6, because all of these x values generate this part of the graph. So the solution to this inequality must be the x values that are greater than 3 but also less than 6, which we could say as the values that are in between 3 and 6. So we write our solution as x is in between 3 and 6. And I've used the regular less than sign here rather than less than or equal to because the inequality in the question was just a regular less than sign. In this question, we've been given the graph of y equals f of x, and we need to draw the graph of y equals f of negative x. When we have f of negative x, we need to reflect the original graph f of x in the y-axis. So let's mark on some of the key points for the graph y equals f of x. We're then going to reflect each of these points one at a time in the y-axis. Let's start with the first point in the bottom left. This point is 4 squares away from the y-axis, so to reflect it, we go 4 squares past the y-axis. This next one is 2 squares from the axis, so we go 2 squares past the axis. This next one's just 1 square, so we go 1 square. The next point is actually on the axis, so that one won't move. Then we come to the next point, which is to the right of the x-axis, but 1 square, so we go 1 square left past the x-axis. And the final point is 3 squares away, so we go 3 squares past. If you now join each of these points up, you'll end up with a graph of f of negative x. In the second part of the question, we're told about point A, which has coordinates 1, 4. Let's mark point A onto the graph. We're then told that y equals f of x is transformed to give the graph with equation y equals f of x plus 1 subtract 1. Point A is going to be mapped to point B, and we need to mark the coordinates of point B. So we need to understand what's meant by this transformation. Well, the plus 1 inside the bracket here means the whole graph is going to move 1 to the left, and this negative 1 outside of the bracket means the graph is going to move 1 down. So all we need to do to find the coordinates of B is move the point A 1 to the left and 1 down. So let's go 1 left, and then 1 down, and we end up at 0, 3. So the answer is 0, 3. In this question, we've been asked to work out the values of x and y. The first thing we're going to notice is this shape here, ABCD, is a cyclic quadrilateral, because it's a quadrilateral where all 4 points are on the circumference of a circle. You should know that the opposite angles in a cyclic quadrilateral add to make 180 degrees. So these two angles here must add to make 180 degrees. So let's take 3x plus 3y, and add to it the other angle, x plus 3y, and this must make 180. We can simplify a little bit here. We've got 3x plus 1x, which is 4x, and also 3y plus 3y, which is 6y. So we have 4x plus 6y equals 180. Next, we're going to look at the tangent at the bottom and the chord CD. They form an angle which has size x plus y. Due to the alternate segment theorem, this angle x plus y must be equal to the angle that the chord CD subtends at the circumference in the opposite segment. That would be this angle here. So we know that the angle here, x plus y, must be the same as this angle here, 4y minus 3x. So let's write that down. X plus y is equal to 4y minus 3x. We can tidy this up a little bit as well. Let's add 3x to both sides. On the left-hand side, if we add 3x, we've got x plus 3x, which is 4x, so 4x plus y, and on the right-hand side, the 3x's will cancel, so we're just left with 4y. Let's also subtract y from both sides. On the left, the y will now cancel, so it's just 4x, and on the right, 4y subtract 1y is 3y. So we end up with these two equations here, linking x and y together. Notice how the first equation has 4x in it, and the second equation says that 4x is equal to 3y. This means we can substitute the 4x in the first equation for 3y. So let's substitute the 4x out for 3y. Now let's take a closer look at that equation. We have 3y plus 6y, which is 9y, equals 180. We can solve this by dividing both sides by 9, and you end up with y equals 20. So we've now found the value of y is 20. Now let's take a closer look at this equation and remember that y is equal to 20. So it says 4x equals 3y, but y is 20, so 3 20s is 60, so 4x equals 60. We can now divide both sides by 4 to get x is equal to 15. So x is 15, and that's the answer to the question. In this question, we've been asked to work out the ratio of the areas of regions P, Q, and R. We've been told the ratio of the lengths from AB to BC to CD. Let's draw out a diagram of this. So if AB is 1 part, and then BC is 2 parts, and CD is square root 19 minus 3 parts. In order to work out the ratio of the areas of these regions, we're going to work out the ratio of the lengths of the pentagons first. If we look at the diagram on the left, the smallest pentagon has a length AB. So we're going to put AB into our ratio. The medium-sized pentagon has a length from A all the way to C, so AC. And the largest pentagon has a length from A all the way to D, so AD. So we want to work out this ratio, and we can do that using the diagram above. So AB is the length from A to B, which is just one part of the ratio. AC is the length from A all the way to C, which is the one part from A to B and also the 2 parts from B to C. So that's a total of 3 parts. And then A to D goes all the way to the end of the line. So we need the 1 part, the 2 part, and also the square root 19 minus 3 parts. Well, if you add 1 and 2, you get 3, but that will cancel the subtract 3, so we will just end up with square root 19. So this is the ratio of the lengths of the sides of the pentagons. Now we want to find the ratio of the areas of these pentagons, and we can do this by squaring the ratio of the lengths. So the areas of the small, medium, and large pentagons are in the ratio 1 squared, which is 1, 3 squared, which is 9, and square root 19 squared, which is 19. So this is the ratio of the areas of the pentagons, but that's not the ratio of the areas of the regions, because the regions aren't just pentagons, but we can use this to work out the ratio of the regions. So for the regions P, Q, and R, the smallest region P is just a pentagon, and that has 1 part in our ratio. But the region Q is the area of the medium-sized pentagon subtract the smallest pentagon. And in our ratio, the medium pentagon was 9 parts and the smallest one was 1 part. So we can subtract 1 from 9 to get 8. And then if we do a similar idea with region R, the area of region R would be the area of the largest pentagon, which we have as 19 parts, subtract the area of the middle-sized pentagon, which is 9 parts. So 19 subtract 9, which is 10. So the answer to the question, the ratio of these regions, is 1 to 8 to 10. In this question, we're asked to work out the perimeter of the pentagon ABCDE. We are told that the lines PR and QR split the pentagon into 3 congruent kites. This means that this kite, and this kite are all the same. We can see there's a right angle in the bottom left corner and bottom right corner of this pentagon, and since these kites are identical, and the kites have 1 pair of opposite equal angles, we can be sure that these are all 90 degrees as well. Next, we're going to draw a line that splits each kite down the middle. This will split each kite into 2 congruent right-angled triangles. If we now look at this angle here, since ARE must be a straight line, this is 180 degrees. And since each of these triangles are congruent, and there are 6 angles here, we can find the size of each of these angles by doing 180 divided by 6, which will give you 30 degrees. So each of these angles here are 30 degrees. Now let's take a closer look at just one of these triangles, for example the triangle RED. We're told in the question the area of the whole pentagon is 75 root 3. And the pentagon was split into 3 congruent kites, so we can find the area of each of these kites by dividing 75 root 3 by 3, which will give you 25 root 3. Since this triangle is half of the size of the kite, the area of each triangle must be half of the area of the kite. So we can divide 25 root 3 by 2 to get the area of the triangle, which is 12.5 root 3. So the area of each of these 6 triangles is 12.5 root 3. Now let's consider how we would find the area of the triangle RED. Well, we would normally do 1/2 multiplied by the base, which we don't know, so we'll just call it RE, and then multiplied by the height, which we also don't know, so we'll call that DE. But we do know what the area needs to be. It needs to be 12.5 root 3. If we now multiply both sides of this equation by 2, on the left-hand side, the 2 will cancel with the half, so we'll just have RE multiplied by DE, and on the right-hand side, 12.5 root 3 multiplied by 2 is 25 root 3. So we find that RE multiplied by DE must give us 25 root 3. Now we can also work out a second equation involving RE and DE. If we label the sides of this right-angle triangle based on the 30 degrees, then DE would be the opposite and RE would be the adjacent. We could then use SOHCAHTOA to write down tan of 30 is equal to the opposite, which in our triangle is just DE, divided by the adjacent, which in our triangle is RE. The exact value of tan 30 is one you should know, it's the square root of 3 over 3. So we've managed to work out 2 equations that involve RE and DE. We could therefore solve them simultaneously. The way I'm going to do this is rearrange this bottom equation so that DE is the subject. I'll do that by multiplying both sides by RE. If I multiply the left side by RE, I get root 3 over 3 lots of RE, and on the right side the RE's will cancel, so we have DE. If we now go back up to this equation here, we can substitute out the DE for what we know it's equal to in the other equation, root 3 over 3 lots of RE. So we can replace DE in this equation with root 3 over 3 RE. So let's rewrite the first equation, RE multiplied by DE, which we're substituting for root 3 over 3 RE, equals 25 root 3. We now have an equation that just involves RE, so we can solve it to find the value of RE. On the left-hand side here, we've got RE multiplied by root 3 over 3 RE, which is root 3 over 3 RE squared. And the right-hand side is 25 root 3. If we multiply both sides of this equation by 3, that will cancel the divide 3 on the left-hand side, so we have root 3 RE squared, and multiplying the right-hand side by 3 is 75 root 3. We could divide both sides by root 3 to cancel those, so we have RE squared equals 75, and then square root both sides to find that RE is the square root of 75. Now this can actually simplify. We can express root 75 as root 25 multiplied by root 3. root 25 we know is 5, so this is 5 root 3. So we found that RE is 5 root 3. But what about DE? Well, if we go back to this equation down here, we can substitute in the value of RE that we just found. So we have root 3 over 3 multiplied by RE, which is 5 root 3, equals DE. On the left-hand side here, if we multiply the root 3 by 5 root 3, we get 5 root 9, and then it's divided by 3, and this will equal DE. The square root of 9, though, is just 3, so we have 5 times 3, which is 15, divided by 3, and 15 divided by 3 is 5. So DE must have been 5. Now let's add these lengths back onto the original diagram, so RE is 5 root 3 and DE is 5. Since these kites are all congruent, we can be sure that QD is also 5, so is CQ, PC, BP, and AB. And because RE is 5 root 3, AR must also be 5 root 3. So to work out the perimeter of the pentagon, we just need to add all of these lengths together. So we have 5, add 5, add 5, add 5, add 5, add 5, and then we add 5 root 3 and another 5 root 3. If you add all of the 5s together, you get 30, and 5 root 3 plus another 5 root 3 will be 10 root 3. And that's the answer to this question. Thank you for watching this video, I hope you found it useful. If you're not already a subscriber, please subscribe so you don't miss out on future videos. And I'd really appreciate if you could take just a moment to like, comment, or share this video with your friends.